Ransomware has been the prominent threat to enterprises and individuals since the mid 2000. I mean, they have no limit in the verticals they target, say healthcare, gaming, aerospace, manufacturing, etc. And we have seen in very recent times some ransomware like Thanos, which is ransomware as a service, has been used by APT groups linked to Iran, named Muddy Water or Static Kitten, and also some of the APT groups like the attributed Chinese who have been using the Polar ransomware and Lazarus as well. In the recent statistics released by Darktracer Intel Group, they said that there has been a total of more than 1,000 victims to the top 25 ransomware groups, which is like Maze or Conti or DarkSide, has been there on last year alone, 2020 alone. I mean, imagine the number is like more than 1,000, and it's still counting. It's just the numbers we know, but there has been something we really don't know, which has been in the dark. But the ransomware which we are going to discuss today is not, or the is not in one of the top lists like Conti or Eger or Mace. The ransomware is they named is Hello Kitty, and we'll come back to you why they name it as Hello Kitty. And it has taken down a gaming company, and that's the reason it was all in the news. But there is a reason for this attack alone to be in the news, because the incident comes on the gaming company called CD Projekt Red, which we all know, and it also comes in the loop that it has been facing months of sustained criticism for its bug-ridden, hyped Cyberpunk 2077 release. The game had so many performance issues, which you would be knowing if you are a gamer. Yeah, on different platforms like that, Sony has to pull it from their PlayStation, and Microsoft was trying to offer some refunds, but it's the other part of the game. But it all happened on last week, that when CD Projekt Red revealed in their Twitter account that saying that they have been a victim of ransomware attack, which uh, which was a bit surprising. But also I would say that it was also very welcome to for them to really accept that they have been they come forward to reveal this part. And they also published in the Twitter the nice ransom note, which seems to a bit customized, which has customized ransomware note mentioning the name of the company, which is CD Projekt Red, and it says that the threat actors have made full copies of their source code, namely which is Cyberpunk, Witcher 3, and some unreleased version of Witcher 3 and G1 as well. And they also dumped all those documents related to accounting, administration, etc. Until this time, we nobody knew this was Hello Kitty Ransomware. It was just the speculation given by researchers in the social media. And in another response in CG, given by the Project Red team, saying that they will not pay ransom, and they are working hard to restore the affected data from the backups. And the speculation that if some big gaming companies like that, or any big companies where their source code being stolen, we all speculate that it's going to be leaked somewhere, or it's going to be sold in some hacker forums. And nevertheless, not to be surprised that in this case it happened the same, because there has been so many leakage of screenshots of this leakage data has been shared in Twitter, in Telegram, in many forums. And there was also kind of announcements from the group itself that they will be releasing the first part of the data today, and the next part, which is the full source code of the Witcher 3, the Cyberpunk, etc., soon. And they will also be selling those in some forums, but at the time we don't know what forum what is, but they were selling those in forums. And soon after that, this kind of leakage came. As I was saying, that there have been many random Telegram channels who was trying to float this data around for free download, as usual, as you know, like torrent links or direct links. And they were also what to say, organizing the data into nice download links where you can quickly download and check on it. And as we are saying that it's quickly this escalated a bit, because there has been a sale and auction of this leaked data in dark web forums. And immediately the first thing we would be checking is write forums, which most we will do. And surprisingly, in write forums, we saw that the threat actor who was trying to sell this was actually trying to paste a screenshot of the leaked data, which was already free available. And there has been some kind of discussion in the social media as well, saying that this is fake, and there has been so many comments below that saying that this is fake, this data is already available, and the threat actor himself saying that is just one part and I have the other part as well. Interesting. And soon after, like less than one day, there has been a post in exploit.in saying that the threat actors will be now auctioning uh, the stolen data, which is again the full source code of Cyberpunk, etc., on Russian time tomorrow. And this the price that was up to, like, the starting price will be up to 1k, and minimum or will be like 500k, and the bidding will end in the next 48 hours. Interesting. And I was just trying to search myself in in this kind of forums, but I mean in this Telegram channels, to see if even this data was actually been leaked somewhere. To my knowledge, nothing was there. And even I was checking in social media as well to see if there's some companies like Kela Security, etc., who has been discussing a lot on this, show that there has been nothing leaked. And soon, within another day, I see that there has been a screenshot that was shared by Kela Security saying that the auction was closed. And the most interesting part is that with with the conditions of further non-distribution. This kind of this wording is a bit strange, because who knows, the person who bought the code from the threat actor can be the team CD Projekt Red itself. And this is not the first time we have seen this ransomware, this Hello Kitty ransomware, especially the one we are discussing now, because I think this was around the news around November, December, when they were trying to hit this Brazilian power plant. And the screenshot was pretty much shared in the social media, that it had the name Kitty Ransomware. So that's why the name Hello Kitty, I think. But also there is another reason, because there has been the mutex in the code itself, which is Hello Kitty. And that's why the name Hello Kitty came in for this ransomware. And also some unnamed healthcare services in the UK and in France as well. And there has been also some analysis on this part that I think it was Cados Security was trying to point out that this Hello Kitty ransomware has heavy code overlaps with another ransomware called Death Ransomware. And if you can see that it almost has half of the code being stolen and written. But at this point of this presentation, I didn't confirm this myself, and I am just trying to post what was shown here. I'm just posting here what I was actually seeing with Integer, and this screenshot was actually taken from Integer. And I will post you this link in the description, and I'll highly recommend you to play with this sandbox, which is quite interesting. And soon I said that there has been the name Hello Kitty came because of the mutex, and I was just trying to search within Virus Total to check on this um, mutex, which is Hello Kitty, and I found that there has been a couple of samples. And if you can see the most latest one, which was first seen in January 2021, and the most last one, which was seen around November. And this maps the timeline, because I think the Brazilian power plant hack was revealed pretty much on early December, I would say. And this is the most interesting thing. When I was trying to reverse this sample, I found a very important code module which was trying to obtain the keyboard layout, which was trying to obtain the keyboard layout. And what's more special about this thing is that it was trying to have some kind of Windows local code, LCID decimal, which is a Windows local code, which is trying to check by obtaining the keyboard layout, which is the Windows local one. And if one of this is present, it's trying to exit itself. And it's pretty much when I was trying to check what are these local codes, keyboard local codes, which is 1049 is going to be with Russian, 105 is going to be Ukrainian, Armenian, Estonian. So I think it's trying to check on all these Russian dialects, and if any of those keyboard matches to one of these Russian dialects, it will try to quit itself. This is something a very interesting point on this ransomware, and this is not the first time we have seen this one, because there have been some ransomwares like Ragnarokler. I have seen already that they have been doing this kind of checks as well. And there have been two variants which I'll show you with the Mutex. One which was most likely in December, and the other one which was most likely in February. So let's just jump quickly to see what's the one in the December one. In this one is that December one is that um, as other ransomware files, it tries to modify the extension of user files. In this case, it was trying to use uh, crypted. And the another interesting thing it was that it was trying to delete itself. That means you will not obtain the copy of the ransomware sample, and it was trying to pretty much do using WMA query for querying the shadow copies, etc. And this pretty much is what the earlier version of the one which was found in December was doing. But the one which was found in very latest one, which is in January, it was trying to use uh, task kill to kill all those processes, and net.exe as well to stop Windows services. Uh, this is very interesting in our part, because as I said, this allocated ransomware, the latest one, has been terminating nearly 1,700 processes in total. That means if it's tried to seize type any kind of processes which is have been hard coded in the code itself, like MySQL or VMware, it will try to task kill itself as many times as it wants, and it will also shut down any kind of Windows services which with the net command, and yeah, delete shadow copies with WMI. We'll be seeing this during the code analysis part. And not to forget the most important thing, I have been using, yeah, and I can see we can already see here that it has been using task kill to kill MySQL, uh, whatnot, IBM, everything. The most important part is in this one is to use the replay monitor. I really like this one because you can save your time from pulling up your VM machine to detonate the ransomware, because you see imagine the amount of net and the task kill Windows has been popped up. So noisy, I would say, because it tries to kill as many services as it's done. And this is an interesting part of the ransomware. And for information, the sandbox I have been using is Triage, and this is something as superior or as equivalent, as not superior, but as interesting as app.aniran or Intezer. And I think you can request a researcher account in this one and start playing with it. Pretty much interesting, because here they will be giving you the download of the sample, the pcap, and the other thing will be is that you can have memory images if you want to perform memory analysis and whatnot. So kind of a nice description of the TTPs, nice IOCs, um, nice command line, and they also give you some signatures, the configuration, what's the malware configuration, I mean the ransom note which they use, the hard coded onion link in the ransom note. You can also look for files that has been invoked by this ransomware, the registries, the network, and whatnot. This gives you as a defender point, in a defender's point, or to do threat hunting. I would say this kind of data is gold mine, and you can start quickly working upon your uh, working upon your process. What can you say? Your playbook, which you follow in your blue team day-to-day life. So moving on. Actually, yes, this is something I really want to point out, is that because this is not the first time that this ransomware has been trying to target a gaming sector, because since we are trying to see something within the gaming industry, I'm trying to say gaming sector, because I think earlier on 2020 during October, September, there was also a post from Eger ransomware that they stole they hacked Ubisoft, and they uploaded the Watchdog Legions entire source code for free download. And you mean, look at the size, guys, it's 558 GB of stolen data that was freely available in the site for quite some time. It's pretty much scary. And now let's quickly analyze the two versions of the ransomware, one which was present in December and one which was present in January. And I will not be walking through the entire code because it will take hours for us to reverse that. But what I will show you is that I have decompiled some interesting subroutines with IDA, and let's quickly compare and contrast to what we have seen in the dynamic analysis to see or to understand the internals of the ransomware.
In this version of the sample, we can see now that it obtains a keyboard layout list, which has a lot, which reads the Windows local in the LCID decimal, and if it sees one of this hard-coded language strings, it's gonna quit itself. In this case, it has hardcore Russian dialects. Sorry, so it is going to be 1049 is going to correspond to Russian, whereas 1061 is going to be Estonian. If it sees any one of these Russian dialects, it's going to quit itself. Not the first time we are seeing ransomware operators are doing these checks, because when I was reversing Ragnarok, I usually saw these same kind of Windows local checks using the keyboard layout list. Also moving on, the other important part we can see is the hard-coder ransom note, which differs from user to user, because every user doesn't have the same ransomware note here. And also the chat onion URI which they have given, which also differs from victim to victim. Here, if you can see that they say that it's going to be dear user, but most of the time when the victim name replaces the dear user here. So let's move on. The other important stuff which we can point out is the usage of threads here. That's why they have been using the command you see do IOCP. The do IOCP is nothing but it tries to perform simultaneous asynchronous input and output operations in window. And furthermore, if we go down, it tries to obtain the system time, lot of thread operations. It wants to obtain the total encryption time in threads, see how much it is free, and what more stuff it has. It's the most important stuff. It's that the ping command and the del command. So it tries to delete itself after after encrypting. And this is the unique part of the differentiation in the character, because this version of the ransomware deletes itself, whereas the later part of the version doesn't have this function. So let's quickly move on to the next one, which calls the do IOCP, and we can clearly see that the usage of AES algorithm here. I think this version of the ransomware uses AES plus NT or encrypt, and pretty much a lot of threads being called, where you can see it uses get logical drives, get drive drive. It tries to obtain all the logical drives, and also it obtains the drive drives. It tries to iterate itself, tries to clean a recycle bin. And the main purpose of the do IOCP here is that, as I said already, it wants to achieve asynchronous input and output operations. And that's why you see that it has this, it has a lot of comments, statements saying waiting search threads job done. So that means it tries to obtain concurrency in threads using the FIFO. So all the process being all the requests, the process that handles many concurrent asynchronous IO requests will be allocated in a pre-allocated thread pool, and it will be served in the first in first out. It's pretty efficient to make things done very quickly. And you can see that it also looks for all the folders from the command line itself as command line as well, because it has this hyphen path given. And finally it tries to make sure everything is completed, and it also waits for all the handles to be processed. Another important module which I would like to also show you is that it has several modules which calls the get current thread ID, and one important module is that it tries to look for files in the drive, and it tries to iterate as much as they can, and it makes sure it doesn't leave any file in the any files within the drive itself. And the final interesting part of this is that it tries to check whether it obtains the process address where to check its WoW64 process. And the most important functionality in this one, we would say that it tries to query the shadow copies using the Windows instrumentation, which is WMI, which is pretty much well known to us, and it tries to delete the shadow copies using this one. Pretty much, this is something uh, unique to both samples of ransomware.
Okay, in the other version of the variant of Hello Kitty, we found pretty much the same functionalities which we found before. Yeah, it tries to obtain it has this mutex here, which is Hello Kitty, and it make sure that it prevents ransomware from running more than one instance. And moving on, yeah, it has the same hard coded. Yeah, sorry, it has the same hard coded ransomware note like we saw before, which has the same dear user, but it depends upon the victim. Also, it has this onion uh, URI for the chat. It's pretty much same for both of these variants to what I can see. You can see here is that in this function here itself it's trying to obtain the command line using the hyphen path, whereas this part of the functionality was actually implemented in a separate module in the previous version. And to move this is where the most important functionality comes in, because this part of the ransomware implements the task kill and the net.exe to stop Windows processes and kill as many running processes as it can, which is pretty much unique to this variant of this ransomware, because in the previous version we never saw this part of the code. We just saw that it was trying to delete itself. And not to forget, this has been trying to delete as much like more than 1,000 processes task kill, and try to use the net stop command to kill more than 50 Windows services. And here you can see that all the hard coded services which is trying to kill using the task kill, a lot and lots of MySQL, VMware, IBM, Symantec I can see, and whatnot. Yeah, moving on, we can again see that it obtains the logical drives using the get logical function, as well as the drive types to iterate them to try to search as much files as it can and begin the encryption process. And here we can see that it implements the same functionality or the same code from the previous variant, where it tries to obtain the the WoW64 process, checks whether it's 64-bit using the get proc address. And moving on, it also uses the WMI query to obtain the Windows shadows copy to delete those using WMI. Select star from a W32 shadow copy, and pretty much the rest of the code remains the same. There is not, but one important functionality which was implemented in this version, which I didn't find in the previous version to what I reversed, maybe I was much quick, is that if this ransomware encounters a locked file when encrypting, it will use this Windows Restart API uh, manager to automatically terminate those processes and Windows services that are keeping the file open. And it pretty much it implements all those Windows API functionalities here, like RM starts session, RM register resources. I think there will be also RM stop something, RM get list, yeah, RM end session, sorry, and RM shutdown, sorry, yeah, RM shutdown. So it uses the Windows Restart API manager to automatically terminate all this process, which that keeps the ransomware blockage when the file is open. Yeah, not least, for both of the variants, it was trying to use the dot crypted extension, and it was trying to use this. The encryption note has been dropped with readme lkd.txt. For both the versions, I think it's the same pretty much, but not much of a difference to check here or to really analyze here.